Welcome to this playlist of Java Under the Hood about Object-Oriented Programming, or OOP. What am I going to cover in this preview? First of all, have a look at the objectives of this playlist. I'll talk about a drawing app, an application we'll develop from scratch, get to know what this playlist is about and what this playlist is not about, so what to expect, the playlist content, the prerequisites, and why another series about object-oriented programming? Because you might wonder, aren't there already loads of them out there? I guess, but I think this playlist adds a few things which you might not encounter easily in other content on the web, so stay tuned. What are the objectives of this playlist? Learn to implement fundamental principles of OOP in a practical way. What do I mean by implement fundamental principles? Well, that the focus lies on implementing them in Java and not on the analysis, although I'll perform a small analysis in the getting started part, the outcome of which I will then use as a starting point of the Java implementations. What do I mean by fundamental principles? Well, I'll cover at least all the buzzwords you might encounter when you hear about OOP. Buzzwords like classes and objects, encapsulation, abstraction, inheritance, polymorphism, interfaces, and much, much more. In a practical way, in this playlist, I'll build a Java program from scratch. And as we go along, we encounter more and more principles that I will explain and implement step by step. What program are we going to build from scratch? I'll answer that question in the following slide. Let me first tell you about Drawing App, which will be the common thread throughout this entire playlist. It's a small program that I wrote in JavaFX, a software platform for creating and delivering desktop applications. And with this application, users can draw rectangles and circles. I admit, not very spectacular, though very useful as a learning platform because a lot of application requirements will be implemented using OOP principles. I'll give a demo in the next video. Getting started. What is this playlist about and what is this playlist not about? It's not about developing a GUI application. GUI stands for Graphical User Interface Application. For example, with JavaFX, nor developing a mobile application, for instance for Android, because actually before we can start to draw rectangles and circles, we need to first define and then implement in Java what a rectangle is, what a circle is. Not in a quick and dirty way, rather in a way which will make our application robust and easily extendable. And by easily extendable, I mean, well, suppose that later on we want users to be able to draw triangles as well, or polygons. That should not be time-consuming or error-prone, which it won't be if our application has been implemented in a sensible way from the start by applying OOP principles. So what is this playlist about? Well, the goal is to first analyze the requirements of the app so as to come up with a clear definition of what a rectangle and circle are. Then second, implement in a Java library, and third, test everything in a Java console application. Plain and simple. The main focus lies here on implementing and testing. And when I say testing, I don't mean that we're going to use unit tests, rather we're going to use the code that we have developed in the library. Once we have that in place, then we can think about what type of GUI app we want to use our defined shapes in. But that will not be covered here. We start from scratch, focusing on OOP principles. What am I going to cover? The first module covers fundamental principles about classes and objects, and they are explained over 9 chapters. In the first chapter, I'll introduce a class and start by defining data as instance member variables. Member variables hold the state of an object. In the next chapter, I'll add behavior to the class, implemented as member functions or methods. Methods enable an object to do things, to act. And we'll encounter the this pointer. Then I'll examine another important principle, namely the need to encapsulate and validate the data. This to help us write a robust and secure application. how are objects initialized. That's what I'll demonstrate in chapter 4 about constructors. In chapter 5 I'll chain constructors, this to optimize constructor implementations. Chapter 6, class member variables, so the static data, and the class member functions, class member methods, or the static functions in chapter 7. Then move on to initialization blocks, which offers a more effective way of, among other things, initialize class member variables. And in the last chapter I'll extend the library with a new class. Until step 8 I'll limit the implementation to the rectangle class. In the last chapter I'll add the circle class in a maybe straightforward way at first, but as it'll turn out, not optimal way. The problem we'll have to deal with is code duplication in similar classes. And that implementation will be kind of our stepstone to the next module, inheritance, which is where we'll improve the implementation of chapter 9. So the second module is called inheritance. Now at the time of this writing I don't have all the videos ready for this module, but what I plan to cover are the following chapters. First, we'll inherit from a superclass, thereby improving the implementation from the previous module. 2, we've talked about class members, so the static members in the previous module, but with inheritance we have to look at it again because we'll encounter a problem once we start using class members in a hierarchy of classes. Chapter 3, inheriting from a class called objects, which is the top class, let's say, of the Java class libraries of the JDK, the Java Development Kit. Now in that class several methods are defined, and we'll have a closer look at toString, equals, hashcode, and the getClass methods. Then move on to the very powerful principle of polymorphism, abstract classes and members, and finally interfaces. So a lot of ground to cover. What are the prerequisites? This is not a Java beginners course in the sense that I expect you to be familiar with the following principles. Java data types, what the primitive types are, byte, short, int, long, etc., and know what they stand for. Also a reference type in general and the string class in particular. Then what it means to declare a variable, what methods are, and then the classical loop and conditional constructs, which you find, I guess, in every programming language, not only in Java. So the while, do while, for loops, the if and the switch conditional constructs, basic knowledge of a class and objects, and know the difference between the two, and what packages are. And with packages come the keywords package and imports. As well, know how to basically use an IDE, so an integrated development environment. For instance, IntelliJ or Eclipse. I'll use IntelliJ. Have one installed and ready to be used. And finally, for the peek under the hood videos, if you're not familiar with method area, stack, heap, stack frame, and so forth, I advise you to have a look at my other playlist first, Stack and Heap Memory Fundamentals, in which I'll explain all those principles in detail. Finally, why another series about object-oriented programming? First, as said earlier, we're going to build an application from scratch, step by step, or chapter by chapter if you like. Second, each chapter will be explained in a few videos, at least 2. One introduction video in which I'll cover some theory, and the second video is the actual hands-on, the practice, where we'll implement in the IDE the principles that we've learned in the introduction. That way you'll be able to follow and implement the Java code yourself. Until here, nothing new, but additionally, with most chapters, there'll be a peek under the hood into the Java virtual machine. Hopefully that'll give you an extra boost, a really thorough understanding about what is really happening when a Java program is running. Because lots of times you might create some code, you get some output, but do you always understand where the output comes from? I hope that with my peeks under the hood, all of your questions you might still have will be answered. And third, this series is what I call solution-driven. At the end of most chapters, we'll encounter a problem. The current implementation will run, but will lack good design or result in code duplication, or something else might be the problem. Whatever the problem, the solution will be given in the next chapter. That's it for the preview. I hope you'll find this series educational and get a lot out of it. Enjoy the rides, and let's get started in the next video.